Hi everyone, we're doing another Math 9 video. This one is on 3.4, which is multiplying and dividing rational numbers. I'm going to go through a few quick examples and then we'll move on to 3.5. So if we have something like 5 times 3 over 7, for example, just a reminder that rational numbers would be anything that has a whole number, a decimal, a fraction, and when we're referring to decimals, it would be the ones that are terminating or they're repeating. So if we have a question like this, it does say 5 times 3 over 7, but we could say that this is like a denominator over 1. So in order for us to be able to multiply these together, we would simply multiply across the top, so 5 times 3 gives us 15, and we would multiply across the bottom. Since it's like there's a 1 there, we are simply left with a 7 at the bottom. And then we do get an answer of 15 over 7, but we don't usually like to leave our answer in this form. This would be called an improper fraction, just to remind you, because the top is bigger than the bottom. But a better way for us to write this is to change it to a mixed number. So just to remind you, while I'm changing it to a mixed number, I would see how many times does 7 go into 15? Well, I know that 7 times 2 is 14, so I'm going to say 2 whole times. And then I would say, okay, well, it goes in 2 whole times, but that gives me 14. And here I have a 15. So that leaves me with 1. And the remainder, or the denominator always stays the same. So the 7 that was at the bottom is also going to be the 7 that's at the bottom in our mixed fraction. So 2 and 1 over 7 is exactly the same thing as 15 over 7. Now, if I wanted to go backwards in the opposite direction, I would take a look at my mixed number and I would say 2 times 7, which is 14, and I'd add the 1 at the top to get 15 over 7. So I know that this is review and you've done this before, but I thought it would be helpful if I quickly reviewed it and just threw in a bit of review while we're going through this. Okay, so moving on to our next example is if we have 2 over 5 and we want to divide that by 3 over 7. Okay, so just to remind you, when we are dealing with division of fractions, the way for us to deal with it is to take this second number and we want to find the reciprocal of this second number. So just to remind you, the reciprocal is if we flipped the top and the bottom here. So another way for me to say this would be 2 over 5 times my flipped fraction. So instead of 3 over 7, I would say 7 over 3. And now I can carry on with the same process as what I did in the last one, which is multiplying the top. So 7 times 2 is 14. And I also want to multiply the bottoms out. So 5 times 3 gives me 15. So this time, if I compare it to the last example, I don't have an improper fraction. My numerator, or the top, is smaller than the bottom. So I can leave it like this and say that my answer is 14 over 15. I'd want to check it to see, is there any way I could simplify it? Like, is there a number that goes into both the top and the bottom so I can reduce it? And in this case, the answer to that is no. So I would leave it exactly as it is. Okay, so let's say this time we have a whole number like 5 and we're dividing that by 1 over 3. So in this case, it's still the same rule that applies, but maybe it's helpful if I change my 5 into a fraction just so we can start to find some similarities. So I would rewrite 5 over 1. I'm going to change this to multiplication. And again, I'm going to take that 1 over 3 and I'm going to flip it to find the reciprocal. So it would be like saying 3 over 1. So in this particular case, when you look at it, the denominator of both of these ended up being 1. So I actually don't even need anything there. This is just 5 times 3, which is a whole number like 15. So that's what we end up getting. Okay, So now let's take a look at a similar type of question. It's still division, but it's set up differently. So we have 2 divided by our fraction, which is 3 over 5. So I don't really need to have brackets there. I'm trying to do a whole number like 2 divided by 3 over 5. But maybe just to make this clear so you can make sense of things, I could put brackets around the bottom or the fraction. But I want to take the same approach as I did in the last one here. So I can set this up to say 2 times, and I flip that bottom fraction. So instead of doing 2 times 3 over 5, I would now do 2 times 5 over 3. So I'm flipping, I'm going to change the brackets into arrows. I'm taking the reciprocal of what was in the denominator. And when I do that, again, maybe it's helpful to view the first one as a fraction as well. You don't have to do that, but it's just for us to be able to keep things organized. And then I go through and I multiply this as I did in the last few examples. And that is multiply the top, so 2 times 5 is 10. And multiply the bottom, 3 times 1 is 3. And this time I once again do have an improper fraction. We don't like having improper fractions. So I want to look at this and say, how many times does 3 go into 10? We know 3 times 3 is 9, so I'm going to say 3. I know the denominator is going to stay the same as what it was here. And then if I did 3 times 3, I'd get 9, but this one is 10, so I'd have 1 left over. And if I ever want to double check to see if that truly is the correct answer, I would look at it and say, okay, 3 times 3 is 9, plus 1 is 10 over 3, which does look like this. So I know that what I've done is actually correct and it works. So you can always go forwards and backwards to double check to see if what you're doing is actually correct. Okay, so this time let's say we have something with a little bit more going on. If we had 4 over 9 times 18 over 24. There's actually a few different ways that we could go through this, but we want to always try to take the easiest route or the more simplified route because that's what's going to make things easier for us to work with. So we are looking for anything that we can cancel out or simplify top to bottom. So if I look at this 4 over 9, there's no number that those two have in common, but if I go across top to bottom here and here, I can say that 9 goes into both of those numbers. So 9 goes into here once, and it goes into here twice. So I can cross that out and simplify it to make it easier to work with. And I can look to do the same thing over here, 4 and 24. Well, 4 goes into both of those. 4 goes into 4 once, and it goes into here 6 times. So I want to rewrite this so that it's super clear what we have and where it's coming from. What I have is 1 over 1 on the left side times 2 over 6 on the right side. And I don't really need the 1 over 1. We know that it's just 2 over 6, but we actually can even simplify this. If I look at the 2 and the 6, 2 goes into there once, and 2 goes into there 3 times. So after going through, simplifying things, crossing things out top and bottom, we end up with a final answer of 1 over 3, which would be our simplified form of 2 over 6. Okay, so now let's throw in there a mixed fraction or a mixed number. So if we have something like 3 and 1 over 5 times 1 and 1 over 4. Okay, so we want to multiply these out. But what I would suggest that's going to make things easier for us to work with is to change them to a form that makes it a bit easier for us to work with it. So let's change these out of mixed fraction form and let's convert them into improper fractions. How I would do that is I would do 3 times 5 gives me 15 plus 1. So I would have 16 over 5. Notice what's happening there. The denominator that's in my mixed number is, well, I don't like that. It's also the denominator in my improper fraction. So I'll show you again with this next example. I would do, well, this is times. 1 times 4 is 4, plus 1 gives me 5 at the top. And the denominator, this 4, just stays the same. It's always the same number that remains at the bottom. Okay, so again, I could just go through and do 16 times 5 and 5 times 4, but that's going to be a little bit harder for us to work with. So I would once again look to simplify if I can. I can't simplify 16 over 5, but I do see that 5 and 5 cancels out here. 5 goes into both of them, so it just leaves a 1. And similarly, 4 goes into 4 once, and it goes into here 4 times. So when I go to do the work to work with this, I would end up with 4 over 1 times just 1 over 1, which is, I could just write 1 over 1, but it's not going to make a difference. So after working our way through all of that, it's much simpler to work with, and we just get the answer 4, which we didn't even have to multiply very much. When we started canceling things out, we were able to simplify it quite a bit. Okay, so I hope that you found that helpful. So for section 3.4, 1 to 8 and 10, I would have you do the odd letters. So just to remind you, that simply means you would do A, then C, then E, so you would be skipping each letter to do half of them.